Okay, so today we're going to start chapter 7. And hopefully I won't pass out from the heat up here. So, the biggest concept in chapter 7, the central concept in this level of chemistry, is something called the mole. And we're not talking about little brown furry creatures, okay? The mole, and a lot of students say, oh, I hate the mole, I hate the mole. You know what? I don't understand why you hate the mole. Because the mole is nothing more than saying, like, you know, that you bought a case of water. Well, how many bottles of water did you buy? You probably bought 24 bottles of water, didn't you? That's what comes in a case, isn't it? Well, the mole is this chemical equivalent to that, right? When the chemist says you have a mole of something, we all know how much of something you have, okay? It's just a way of bringing stuff together. So when I say, hey, go get me a dozen donuts, how many donuts are you going to get me?
12.
12. Mm-hmm. Not that I need a dozen donuts, but, you know, we all know that. Now, in chemistry, the mole is called Avogadro's number. It has a number associated with it, and that number is called Avogadro's number. If you have 1 mole of something, so instead of having a dozen donuts, you now have 6.02 times 10 to the 23rd of whatever it is you have. Now let's think about this number, 6.02 times 10 to the 23rd. A couple of things to go with this number. It's called Avogadro's number. Meaning what? How many numbers have we seen so far that had somebody's name associated with it? Have we seen any numbers that had somebody's name associated with it? I don't think so, right? So what do you think that means about this number? Pretty important. The guy that came up with it, pretty smart guy. And what do you think you need to do with this number?
Write it down.
And do what with it?
Study it.
Remember it.
Write it down, learn it, live it, use it, know it. I.e., it'll be on the test, okay? You must know Avogadro's number. Now, the other thing is, this is a pretty good sized number. Look at that exponent. And look at all them zeros. Okay? How big is this number? Extremely big? How long do you think it'd take you to count to Avogadro's number? A couple years? Anybody else? Let's give it a shot. A few years? A lifetime? How about if I told you it might take you a few billion lifetimes to count that high? Holy crap. Batman. Yeah. Because a billion's only 10 to the 9th. That's 10 to the 23rd. That's still 10 to the 14th times more. Okay. How can you have a mole of anything if it's that big? Okay, here's how big a mole is. If you had a mole of baseballs, how big a volume of baseballs? Would you be able to put it in the back of your pickup truck?
No.
Would you be able to fill up this room with it? Would it fill up the Panther Stadium? You know what the Panthers are, a football team,
Yes.
plays in Charlotte. Would it fill up their stadium? Would it overflow the stadium? By how much? If you had a mole of baseballs, you'd have something that was the volume of the earth, basically. Holy moly. All right. In my 151 class, sometimes they do a calculation on the mole. If you had a mole of sand grains, okay, and you piled them up on the state of Texas, even it out, how much sand do you think you would cut? Texas is a big state, right?
Mm-hmm.
How deep do you think the sand would be on the state of Texas if you covered it with a mole of sand grains?
said it was, how much to the world?
How deep do you think it would be on the state of Texas if you covered Texas with a mole of sand grains? You'd have like 3 feet of sand all over the whole state of Texas. That's one of the calculations I make them do. They don't like it. What is this saying about a mole? Have you ever held a mole in your hand?
No.
Yes, you have. Well, if a sand grain, if you had a mole of sand grains and it covers Texas, but you've held a mole of something in your hand, that something you're holding in your hand, one of them must have been really small, right? Okay. What a mole allows us to do is to scale from something that's not really usable, an atom or a molecule, up to a usable quantity. Like a dozen donuts scales from one donut, which is not really usable for anything, up to a dozen donuts. Because nobody eats just one donut, right? That's just wrong. Or a bag of potato chips. Nobody buys one potato chip, do you? A whole bag. Well, this is like a bag of atoms. There's 6.02 times 10 to the 23rd. An atom is so small that that's how many you would hold in your hand if you had a mole of them. Okay? It's unbelievable how small an atom is, and this number is unbelievable how big it is. Okay? It's so big that there has never been that many people alive on Earth. Okay? Not even close. Okay? Does that make sense? I struggle. I never can come up with a number that can make, with an analogy that makes my students understand exactly how big this number is. I can't ask you to count that high because you won't live long enough. The scale factor here is so vast that it's difficult for most people to understand how big it is.
It's like trying to count stars.
Yeah, it's like it's even worse than that, right? Because stars, there is a finite number of them that you can see. This is, if you covered the sky with this many stars, the whole sky would be lit up, right? There wouldn't be any black space. It would cover the entire sky, okay? It's an unbelievable number. And this guy, Amadeo Avogadro, figured this out. That you can scale from atoms up to moles using this quantity, okay? Note that it is an equality. 1 mole equals 6.02 times 10 to the 23rd. What do you think that means for us when you see an equality like that? What do you think we're going to do with this number?
Use it in a conversion.
Use it in a conversion. Very good. Give that lady a cigar. You never heard that saying?
Yeah.
Yeah. All right. If you have 1 mole of anything, you have Avogadro's number of it. So you could have a mole of carbon. You would have 6.02 times 10 to the 23rd atoms of carbon. You could have a mole of sodium. You would have 6.02 times 10 to the 23rd atoms of sodium. Okay? It doesn't matter what substance you have. If you have 1 mole, this is how many atoms you have. Or if you have molecules, you would have 6.02 times 10 to the 23rd molecules. For instance, this bottle of water right here, when it was full, I'm going to make a guess here. Who's got your calculator out today? Who brought your calculator? We're going to need them today. Somebody divide 591 by 18 for me. 33. So when this bottle was full, it had actually 33 moles of water in it. What does that say about a molecule of water?
They're very, very, very,
Very small if I can put 33 moles in here, right? Okay. But when I have 1 mole of water, I have 6.02 times 10 to the 23rd molecules. Okay. Note on the last one down here, 1 mole of sodium chloride is 6.02 times 10 to the 23rd formula units. Why do we call this formula units and not molecules? I know.
They're not worded properly. You get 2 things.
What kind of things?
Elements.
Yeah, but the other one, water has 2 elements and it's a molecule. Why sodium chloride? Why don't we use formula units and not the word molecule?
It's an ionic compound.
Because it's ionic. It's not a molecule.
I could find the word.
Huh?
That's what I meant.
I'll grade your tests like that too. I'll read your mind. Oh, this is what she meant. Right? Okay. When you have ionic compounds that are not molecules, you talk about formula units, okay? I like to call them FUs. That's what I call them. Formula units is too much to say. Just call them FUs, okay? F dot U dot. Not saying anything bad, okay? So, 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. So we can write 2 conversions from that, right? 1 mole over 6.02 times 10 to the 23rd, or 6.02 times 10 to the 23rd over 1 mole. Okay? Make sense? Because it's an equality. 1 mole of anything equals that many of them. So if I had 1 mole of students, I would have 6.02 times 10 to the 23rd students. Okay? Fair enough? So, how are we going to do a calculation? Let's see, how many students do we have? So the question is, where do you think we're going to start? Where can we start? Well, we only have 1 number, right? So why don't we start there? 0.5 moles of carbon dioxide. Then what are we going to do? We want to find what? Molecules. What has to go on the bottom right here?
Moles of carbon dioxide.
Moles of carbon dioxide. Why? Well, because it was on top right there, right? Remember that way back when?
Mm-hmm.
Well, what can I convert moles to? Can I convert moles into molecules?
Yes.
What did we just say? 1 mole, 6.02 times 10 to the 23rd molecules of CO2. Everybody do that in your calculator? Should be easy. .01 times 10 to the 23rd molecule.